You ever snap a picture of a receipt with your phone or wonder how Google is able to digitize millions and millions of books? Well, for a long time, the magic behind all that has been a technology called optical character recognition, or OCR. And right at the heart of that whole story is one truly legendary engine. I mean, it seems so simple for us, right? We just look at it. But for a computer, a page of text is just, well, it's a bunch of meaningless pixels. So how in the world does it learn to tell an A from a B and then string all that together into words and sentences that actually make sense?
Well, for developers and companies who needed a powerful way to do this without spending a fortune, one name has come up again and again and again: Tesseract. It's the open source workhorse that has powered countless projects, pretty much teaching computers how to read for decades. To really get why Tesseract is such a big deal, we've got to go back. We're talking about a journey that spans over 4 decades of incredible innovation.
Okay, let's just take a look at this timeline, because it's pretty wild. Tesseract starts off as a PhD project at HP way back in 1984. But get this, by 1995, it was already going toe-to-toe with really expensive commercial software and winning in accuracy tests. Then, the real game changer, 2005. HP releases it as open source. Suddenly, anyone could use it. And today, it's maintained by Google and it's a global powerhouse, understanding over 100 languages.
So what's actually going on under the hood? How does it work? Well, Tesseract doesn't just see the text. It follows this really clever, systematic process to break down an image and figure out what it says.
The whole thing is basically a 4-step pipeline. First, it has to find all the lines of text on the page. Then it figures out the baseline for that text, even if it's curved. From there, it chops the lines into words and the words into individual characters, and only then, at the very end, does it try to figure out what those characters actually are.
Now, this is where you start to see the genius of Tesseract. It was built for the real world, for messy scans. Most of the early tools, you see, they made you perfectly straighten an image first, which actually could degrade the quality. But Tesseract, its line finding is smart enough to find the text even if you scanned the page crooked.
And here's another brilliant little trick. You know when you try to scan a thick book and the text just kind of curves down into the spine? Yeah, that was a huge headache for early OCR. Tesseract was one of the very first engines to solve this by fitting a flexible, curved baseline to the text. It could read those words that other engines just couldn't. And it's just as clever when it comes to messy text. So let's say 2 letters are smushed together in a bad copy. Tesseract intelligently finds the best place to chop them apart. Or, if a letter is broken into pieces, it has this cool associator that puts the fragments back together, kind of like a tiny puzzle.
But here's the secret sauce: adaptive recognition. Tesseract actually gets smarter as it reads your document. It does a first pass and finds the easy words. Then it uses those words to train itself, on the fly, on the specific fonts and styles in that document. Then it does a second pass, and with what it just learned, it goes back and tackles the words it struggled with before. It's literally learning on the job.
Okay, so that's the clever engine. But what's it actually like to use it out in the wild? Let's get into the developer's reality, because using Tesseract isn't quite as simple as just flipping a switch.
See, in the real world, developers almost never use Tesseract by itself. It's the core of a whole toolkit. You'll have something like PyTesseract, which is a bridge that lets you use the C++ engine from Python. The Leptonika library is doing the heavy lifting on image analysis. And, this is critical, you're almost always using a library like OpenCV to clean up and prepare the images before Tesseract even sees them.
And that pre-processing step, it's absolutely non-negotiable. Because here's the stark reality. On a perfect, clean image, Tesseract might get you, say, 70% accuracy. But if you feed it a blurry photo with bad lighting, that accuracy can just plummet to 30% or even lower. It's the classic case of garbage in, garbage out.
And all this brings us to the big question for today. Tesseract is a legend, no doubt, but the world is changing fast. So how does this classic engine really stack up against the new wave of powerful AI tools?
Yeah, the market is not waiting around. A recent study showed that nearly 8 out of every 10 large companies are already using AI for their document workflows. The shift away from older, more manual systems is happening, and it's happening fast.
And when you put them side by side, well, the differences become pretty clear. Modern AI solutions often hit accuracy rates over 95% right out of the box. They're built to be plug and play, many can handle handwriting, and they come with advanced stuff like fraud detection. Tesseract, on the other hand, needs a lot of manual setup and training, and just doesn't have those AI features built in.
Just look at the chart. Visually, the accuracy gap is the whole story. Even if we're being generous and say you can get Tesseract to 80% on a perfect image, the top AI platforms are just in another league. They're consistently hitting 95% or even higher.
So it all comes down to this one final really practical question for any developer or business. Tesseract is free, but is free actually the best price for what you need to do?
This quote just hits the nail on the head. Sure, the software license doesn't cost anything, but the free price tag doesn't include the cost of your developer's time, the hours and weeks they might spend setting it up, pre-processing images, and doing maintenance. You're basically trading money for time.
So look, Tesseract is still an amazing choice in the right situation. If your task is simple, like reading text from clean, standardized documents, and you've got the engineers who can manage it, it's an incredibly powerful and cost-effective tool, no question.
But on the other hand, if accuracy is everything, if you're dealing with messy and varied documents, or if you need those advanced AI features, then a modern AI platform is almost certainly the smarter investment. The license fee often pays for itself many times over in saved developer time and just plain better results.
Which leaves us with one final thought. In a world where AI is getting more and more powerful, what is the role of a classic open-source tool like Tesseract? Does it fade away? Or does it remain one of those essential building blocks that the next generation of technology is built on top of?